Now we have prime and composite numbers. Now where do they belong, or which set do they belong to? They actually belong to set of natural numbers. Natural numbers are divided into two types: prime numbers and composite numbers, on the basis of the factorizability of the number, on the basis of number of factors of the number. Okay, so prime numbers are those, we have already seen, prime numbers are those natural numbers which are divisible by exactly two numbers. Okay, what are those two numbers? 1 and itself. So in proper words, we can say that the numbers having exactly two factors. And what are those two factors? 1 and itself. Be very clear that it has to have two distinct factors. Two distinct factors. That's a very important condition. Now, composite numbers, the numbers having more than two distinct factors. Okay, so you can say that numbers which are not prime are composite. Is that so? Let's see. What about 1? So if you see 1, in case of 1 and itself become same. So there is this condition is violated. So what does it mean? If I say 1, the factor of 1 is only 1. So it does not have two prime factors or two factors. Right? It does not have two factors. It has only one factor. So it cannot be put in the category of prime. Composite numbers having more than two factors. All the more difficult for one to go into composite numbers. So 1 cannot be a part of prime numbers. 1 cannot be a part of composite numbers. So where do we keep 1? 1 is the king of natural numbers. So 1 will be kept here. So remember, 1 is not prime number. 1 is not composite number. Right? It is just non-prime, non-composite, natural number. That's it. Right? You have to be very carefully understand these facts and memorize them. Okay. Now the next challenge is to identify, how to identify whether a given number is prime or not. So what are the prime numbers? Let's take some examples. What is the first prime number? The first prime number is 2, then 3, then 5, then 7, and so on. Right? What about the first composite number? So 1 is not prime, not composite. 2 is the prime number. 3 is the prime number. 4. What are the factors of 4? 1, 4, and then 2. So 3 factors. That means 4 is the first composite number. Next composite number would be 6, then 8, then 9, then 10, then 12, and so on. Right here, 2, 3, 5, 7, 11, 13, 17, and so on. I hope you can see that there is no simple pattern for prime numbers or composite numbers for that matter. There is no simple pattern. Okay, be very careful. Here, the consecutive. Here, difference of 2, difference of 4, again difference of 2, again difference of 4, then 19, then 23. Then 29, so 6 ka difference. So there is absolutely no pattern. Okay, so there is definitely no pattern for prime numbers or composite numbers. Right? One question can be, how many prime numbers are there in the first 100 natural numbers? So let's count prime numbers in the first 100 natural numbers. Okay, so what I've done is I've divided into the groups of 10. Let me say, in the first 10 numbers, what are the prime numbers? 2, 3, 5, 7. In the next 10 numbers, what are the prime numbers? 11, 13, 17, 19. In the next 10 numbers, you can check. How would you check? I'm sure one that you are aware. The other thing would be that you can check the divisibility. You know, whether a given number is divisible by any of the other numbers or not. If it is not divisible by any of the other numbers, that means it is a prime number. As simple as that. For bigger numbers, we have method, but for smaller numbers, we should know, or we should just use tables to find. Yeah, and that's why I'm saying it is very important to identify all the prime numbers from 1 to 100, and keep them in your mind. I mean, they're like your name, address, phone number, like that. Okay. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. So 1 to 10, 11 to 20, 21 to 30, 31 to 40, then 41 to 50, 41, 43, 47, then 51 to 60, 53, 59, Then 61 to 70, 61, 67. Then 71 to 80, that is 71, 73, 79. Then 81 to 90, that is 83 and 89. And very interestingly, from 91 to 100, there is only one prime number, and that is 97. Some of you may come up with the idea of 57 or 51 for that matter. Then you have 87, 91, 93. 93, it is shouting loudly that I'm divisible by 3, if you can see that. There is 9 and there is a 3. जोर जोर से चिल्ला के बोल रहा है मैं 3 से divisible हूँ, तो ये तो नहीं होना चाहिए. 91 is in table of 13. 13 sevens are in 91, so it is not a prime number. Rest of the 3 numbers you can actually check the divisibility of 3. Are you aware that divisibility of 3 is dependent on the sum of digits of the number? What do? You add the digits. Say 51. If you add the digits, 5 plus 1, that is 6. If the sum of digits is divisible by 3, then the number is divisible by 3. So 51 is divisible by 3. 57. 5 plus 7, that is 12. 12 is divisible by 3. So 57 will also be divisible by 3. 87. 8 plus 7, that is 15. 15 is divisible by 3. For that matter, 9 plus 3, 12, that is also divisible by 3. So all these numbers are divisible by some or the other number. Hence, they are not prime numbers. Okay. Now, if we count them, in the first 10 numbers, how many prime numbers are there? 4. In the next 10 numbers, how many prime numbers are there? 4. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 3 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 2 prime numbers. Next 10 numbers, there are 3 prime numbers. Next 10 numbers, there are 2 prime numbers. Next one, the last one, there is only 1. Okay. So if I make the series, it is 4, 4, 2, 2, 3, 2, 2, 3, 2, 1. So in this manner, you understand, these are number of prime numbers in a decade. If I can use the word decade for 10 consecutive natural numbers like this. Okay, so in every 10 numbers, so first 10 numbers there are 4 prime numbers. Next 10 numbers there are 4 prime numbers. The next 10 numbers there are 2 prime numbers. In the next 10 numbers there are 2 prime numbers. Then 3, then 2, 2, 3, then 2, 1. So it becomes actually rhyming 4, 4, 2, 2, 3, 2, 2, 3, 2, 1. Now, what is the total number of prime numbers from 1 to 100? Either you add these numbers or you count actually from here. Whatever you do, you get 4 plus 4, 8, plus 2 plus 2 plus 3, that is 7, 15, plus 2 plus 2 plus 3, that is 22, 24 and 1, 25. Or you can simply count 1, 2, 3, 4, 5, 6, 7, 8 and so on. So there are total of 25 prime numbers. So total 25 prime numbers from 1 to 100. That's what we said. The first 100 natural numbers. First 100 natural numbers means from 1 to 100. So there are a total of 25 prime numbers from 1 to 100. Are we clear in this? There are a total of 25 prime numbers from 1 to 100. How many composite numbers are there? Can somebody tell me how many composite numbers are there from 1 to 100? Check karo. So I think 75, and I'm sure you are wrong. That it cannot be 75. Why? How many numbers are there from 1 to 100? 100. Out of them, 5 are prime numbers. And there is one number, 1, which is neither prime nor composite. So when you go on counting composite numbers, what you have to do is number of composite numbers. If I say composite numbers in the first 100 natural numbers, what do we have to do? We have to remove something from 100. What all do we have to remove? Total 26 we have to remove. Why 26? 25 prime numbers and 1 which is not prime, not composite. Total 26 numbers have to be removed. So the answer would be 74 numbers. So from 1 to 100 there are 74 composite numbers. So 25 prime numbers, 74 composite numbers and 1 which is not prime, not composite. Okay. So this is how we check whether a given number is prime or composite. Right? For smaller numbers, tables and small divisibility tests will help you. For larger numbers, how would you identify whether it's a prime number or not? First of all, in your examination, difficult numbers wouldn't be asked. I'm not saying that this question cannot be asked. Questions will be asked. bigger numbers may be asked, like which of the following is not a prime number, and there'll be prime numbers, or there'll be numbers of 6 digit, 7 digit, 8 digit. Trust me, you will have to only use divisibility test. You are not required to know more than 2 digit or 3 digit numbers. So don't worry about it. Right? It will be simple. You just have to check the basic divisibility of that number by smaller prime factors like 2, 3, 5, 7 and so on. Okay? That we'll see when the questions come.